Now next is rectangular resolution of a vector. Alright, let us say we have OX, OY and OZ. This be three mutually perpendicular axes, OX, OY and OZ. Let us consider this OX, OY and OZ be three mutually perpendicular axes and form a right-handed system of direction. Alright, so if you expand your right hand with three fingers, index finger, thumb and your middle finger, alright, let us assume. Now system of direction is Y to Z, Y to Z and Z to Y, Z to X and X to Y. So you can see system of direction is Y to Z and Z to X and X to Y. Alright. Now let us assume three unit vector, that is I, J and K, be the unit vector along these three mutually perpendicular axes OX, OY and OZ. Now if we consider OP, then it is nothing but which is R. As you can see, OP is R. Alright, and the coordinates of P be X, Y and Z. So we have already assumed this thing within the diagram. Alright, then vector OA is the orthogonal projection of projection of R. As you can see, OA, this is nothing but it is the orthogonal projection of this R. This is the orthogonal projection of this R. Alright, and direction is given by XI. Similarly, OB is equals to YJ. Similarly, OC is KZ. Alright, OA is XI and OB is YJ and OC is KZ. Alright, here X, Y, Z are the rectangular component of R. As you can see, this XYZ is the rectangular component of this R. Alright, now we have vector OP which can be equivalent to vector OF plus FP. Can we say that vector OP, this is equivalent to OF plus FP, this according to the rectangular law of addition. So this is a rectangular, see, OPF, and OP can be equivalent to this plus this. Alright, so therefore we can say that vector OP is equals to OF plus FP. Alright, if we can say that this vector OP is equals to OF plus FP, again we can say that vector OF is equivalent to vector OA plus vector AF. Again we have FP. So this OF can be represented as vector OA plus vector AF. How? Vector OF is here. This is equivalent to vector OA plus AF. As you can see, it is forming a triangle. So therefore we can say that vector OF is equivalent to vector OA plus vector AF. Alright. Again we have FP. Yes or no? So now we can say that vector OA plus vector AF alright. Now we can say that vector OA plus vector OB plus vector OC. How we can say that this thing? OA is already here, alright. AF can be said as OB. Why? Since AF is here, AF is equivalent to OB. Since it is in parallel, we can say that AF is equivalent to OB. In place of vector AF, we can say that vector OB. Alright. Similarly, FP. Where is FP? Here we have FP. Vector FP is equivalent to vector OC. Since it is a parallel, so therefore we can say that we can replace this vector FP as vector OC. Alright. Now this is nothing but OP. So if this is our final term, then we can say that OP is represented by R, which is equivalent to OA is represented by XI, plus OB is represented by YJ, plus OC is represented by ZK. Alright. So here you can see OP is represented as R, and vector OA is represented as XI, so therefore we can say that it is XI, and vector OB is represented by YZ, so therefore we can say that YZ, and vector OC is here, so it is represented by ZK, so therefore we can replace this as ZK. Now if we square both sides, so therefore squaring both sides, we get R square equals XI whole square plus YJ whole square plus ZK whole square. Alright. Since IJK is a unit vector, so therefore we get R square is equals to X square plus Y square plus Z square. We get R is equals to under root of X square plus Y square plus Z square. And henceforth we call it as magnitude of R is equals to under root of X square plus Y square plus Z square. So this is our length of R, or magnitude of R.
If you love our content, don't forget to subscribe and share it with your friends. For even more amazing resources, visit our website and experience the ultimate in learning. The link is in the description below. Join the elite learning community.